Hello everyone, this is Mansa, currently pursuing BTech first year in Vasireddy Venkatadri Institute of Technology. Today I am going to present my seminar on encoders and priority encoders. So let me share a screen. First of all, what is meant by encoder? An encoder is a combinational circuit that performs the reverse operation of the decoder. It has maximum of 2 power n input lines and n output lines. Hence, it encodes the information from 2 power n inputs into an n-bit code. It will produce a binary code equivalent to the input, which is active high. Therefore, the encoder encodes 2 power n input lines with n bits. The logic diagram for the encoder is as follows. There will be 2 power n input lines and only n output lines. Uses of the encoders. Encoders are very common electronic circuits used in all digital systems. Encoders are used to translate the decimal values to the binary in order to perform the binary functions such as addition, subtraction, multiplication, etc. Other applications, especially for priority encoders, may include detecting interrupts in microprocessor applications. Encoders are very common electronic circuits used in all digital systems. 4x2 encoder. The 4x2 encoder consists of 4 inputs y0, y1, y2, y3 and 2 outputs a0 and a1. At any time, only one of these 4 inputs can be 1 in order to get the output respective binary code. The figure below shows the logic symbol of 4x2 encoder. There will be 4 inputs y0, y1, y2, y3 and only 2 outputs a0 and a1. The truth table of 4x2 encoder is as follows. The y0 represents decimal 0. So it will be coded in the binary form 0, 0. Y0 represents decimal value 1 and it can be coded as 0, 1. Y2 represents decimal number 2. It is coded as 1, 0 in binary. Y3 represents decimal number 3 and it is coded as 1, 1 in binary. Logical expression for A0 and A1. The corresponding equation for A0 is y1 plus y3 and A1 is y2 plus y3. The above two Boolean functions A1 and A0 can be implemented using two input OR gates. Drawbacks of normal encoders. There is an ambiguity when all outputs of the encoder are equal to 1. If more than one input is active high, then the encoder produces an output which may not be the correct code. So, to overcome these difficulties, we should assign priorities to each input of the encoder. Then the output of the encoder will be the code corresponding to the active high inputs, which has higher priority. Priority encoder. A 4:2 priority encoder has 4 inputs, y0, y1, y2, y3, and 2 outputs, a0 and a1. Here, the input y3 has the highest priority, whereas the input y0 has the lowest priority. In this case, even if more than one input is 1 at the same time, the output will be the binary code corresponding to the input, which is having higher priority. The truth table for priority encoder is as follows. There are the inputs y0, y1, y2, y3. Y0 represents the decimal 0 and it will be coded as 0, 0. Y1 represents decimal 1 and it can be coded as 0, 1. Y2 represents binary decimal number 2 and it can be coded in the binary as 1, 0. Y3 represents decimal number 3 and it can be coded as 1, 1. If the decimal number 3, that is Y3 is 1, if Y0, Y1, Y2 are either zeros or ones, the priority is given to the Y3. Now we will draw the K-maps for both A0 and A1 and the corresponding equation for A0 is Y1, Y2 dash plus Y3 and the corresponding equation for A1 is Y2 plus Y3. The above two Boolean functions can be implemented as follows using OR gates, NAND and NOT gates. That's all. Thank you so much for giving me this opportunity. Thank you.